everybody to my talk. My name is Julian Haag. I'm from the Department of Information Computer Science at Utrecht. We do a lot of Haskell. In fact, most of our lecturers and assistant professors have their own Haskell compiler. Otherwise, then you're not taken seriously. So at the UNC, at Oxford and Deutsche, we have had the generic Haskell compiler of Andres and Johan Juring. I didn't have one, so I procreated the Helium compiler. I apologize also for not having any GMATs and type values in the Helium code, because it was built before we had them in Haskell. I hope you understand. So the good news, I think, is that Helium is now available on Hackage. But what is Helium before you start to install it? You want to know what you get into. So Arjo van IJsselen used to be a lecturer in our group. He was fed up by the bad error messages of hubs that we were using in our functional programming course, and GHC is not much better. So he said, I want to build my own compiler for a subset of Haskell, and maybe I do a lot of stuff that, as long as I can give good error messages. So this Haskell workshop paper in 2003, the compiler was built in 2001, 2002. It's Haskell 98, but you can't have any class or instance technology. There's a few others. So there's particular attention paid to type error diagnosis, and this is serendipity in action. Arjo van IJsselen had this idea, and Bastiaan Heer and I were working on improving type error diagnosis, instigated by Deutsche. And so the nice thing was that Bastiaan could experiment with his work in the setting of a real compiler. It's used in education, so in few places I know. And in fact, getting actually Helium ready for Hackage this year, I mean, I've been wanting to do this for years, was because Annette Birusa all of a sudden had to teach a Haskell programming course somewhere in Germany. She said, what about Helium? Can I use it? So made the effort. So it's support for tailorable error diagnosis, but it turns out that if you say domain specific, everybody thinks it's hot. Maintained mostly at the moment by Bastiaan Heer and myself. It's also used by other systems like the Haskell system, or tutoring system by Arlax Verdes. So to get it, Helium 1.8, you just do cobalt install Helium and then cobalt install LVM run, and then you can use two programs, textint and run Helium. That textint behaves like a GHCI, that's good, but still. And you have a run Helium that basically behaves like Haskell. So while you have that compiling, okay. So what do you get if you install this? Well, you get a compiler that's targeted to novice programmers and those who have bad error messages. It also has Helium as a library. This was also important for like Bastiaan, because they actually compile two parts of Helium that they reuse the parts, so they reuse the typing address and stuff like that. It's Haskell 98, minus a few details. So no epicas plus k-factor, we already threw them out before Haskell did. There are no class and instance definitions, there's a simpler offsite rule, a simpler module system, because it was intended for education. It has a built-in logging facility for storing student compilers, and you can experiment with various type inference algorithms and those based on. And I think importantly, it supports the domain-specific type error diagnosis. We have a paper about that with ICFP 2003, it's still in there, it's still working. And I have some more about it. It also motivated GHC, I think, assignment for better error diagnosis. In fact, when I was working, I'm also teaching FP, that's why I got here only yesterday. I was teaching FP last Thursday to a group of 250 students. And I found when I was rewriting the lecture notes, updating them, that in the lecture notes there was an error message that Helium gave and an error message that GHC gave. But this was pretty old GHC that was generating these error messages. And I was rerunning all of that to see what happened. It turns out that basically GHC gives the error message that Helium used to give 10 years ago, still gives. So a lot of improvements have been made, I guess, also in GHC. And I like to think that this is the reason it exists.
It might even be true.
All right. Lots of people say, when you say, do you know about Helium? People say, I've heard about Helium, it doesn't support type classes. And that's all they remember. So actually it has two flags, no overloading and overloading. And actually no overloading means you have no type classes altogether. You get great error messages if you write 1 plus true. If you write minus minus overloading, that's actually the standard. So if you run textint, you just have overloading, but you just get 5 built-in classes. And you cannot write your own instances. And deriving is for EQ and show. So for example, if you want to teach your functional programmers how to write type classes, don't even use it in our own functional programming course because I want students to write their own type classes and instances and do all that stuff. That's it. And actually, Jeroen Weijers actually built parsing and type checking, but we never went around to code generation. So maybe in the near future something. There are limitations, so I already told you that it's support language is not enough for learning to program Haskell in our own programming course, but I do know about universities where they actually use Helium for teaching. So for that it's enough. It's for a certain time comparable or better than Hugs, but even without code optimization, but I expect to go way behind GHC, but for educational tools, it's fast enough. There are some bugs in there, see on the website there. Some of them are pretty hardy because they're hidden deep inside C++ code that Dan Lai ripped out of the Ocaml compiler 15 years ago. I'm trying to fix them. I don't get a lot of sleep these days. But I mean, they hardly ever show up. Documented when they show up. So I still like to work on that. It has extensions too, so polymorphic kinds have been in Helium for about 10 years or so. If you know how to find the flag. Helium, so one thing that bothered me for a long time is getting it onto Hackage. It has its own libraries, two variants because we have overloading and non-overloading. So we have a non-overloading prelude, an overloading prelude. Where is it? I also wanted to have multiple Heliums side by side for my work on error diagnosis. And actually Cabal helped me do this in a platform independent way. That'd be great. So now Duncan is happy. Cabal. Something positive about Cabal. Very good. Of course, platform independence in other places still is still a pain. So we still discover all kinds of slashes somewhere that should be platform independence, path separated, blah blah blah. So one thing we did run into is that we use Cabal's make build type for building down lines LVM interpreter because the LVM interpreter that down made, and I'm not going to rebuild it, is pure C++. No Haskell at all, nothing of it. And so you need configure script, make type, blah, blah, blah. And the make build type is very undocumented. In fact, I think I checked on Hackage, there is no Cabal package besides this one that has the make build type. So it's undocumented, not very robust, but in the end I got it to work. And I mean, to be honest, in documentation it says that maybe you shouldn't be using this because nobody uses it and it may work. But actually, it does work. It took me 3 years to get it to work. But the nice thing is that rolling out the new Helium is quite easy for me. Distribution problem happens. So some credits before I give you some examples of the type error diagnosis, specifically the domain-specific type error diagnosis, because I think that's a nice thing. And it's also something we're working on at the moment. So Arjen Eijzen was the originator, and together with Bastiaan, the main implementer of the compiler. So Dan Leijen contributed this LVM system. I did, together with Bastiaan, the type system research and the integration of the room system, and I did about the Helium environment. And there's a few people here in the room that have also contributed in their sometimes minor or sometimes major ways. So Anders Leun, Roosje Sierstein, Alexander Zuiling, I don't think anybody else is so lots of people have seen that. Maybe Alex Curtis. So, improving type error diagnosis. So there are lots of error diagnosing heuristics in Helium. The idea is that if you detect an inconsistency in some plain Haskell code, we have lots of heuristics that try to decide what is the most likely cause of the problem. Note, however, heuristics can always point you in the wrong direction. And so also, although we do make some effort to decide, okay, if 3 heuristics scream it's this mistake, but and they're different, then maybe we don't want to use any of them at all. We do have some confidence levels that work into that. But sometimes, so for example, you want to have the minimal number of type errors, because Helium actually doesn't just give the first type error, but it just gives a list of type errors, eventually. You can count the number of occurring clashing type constants, so if 3 things say it's int and 1 case says it's bool, it shouldn't depend on the order in which you discover these things. Normal in a non-constraint-based setting. We prefer to report type errors on expressions and not on patterns, wrong literal constants, not enough arguments supplied, and it will suggest, okay, supply an additional argument of this and this type, and it will work. It can tell you to permute the elements of a tuple, permute the arguments to a function. things like that. So these are the kind of error messages, so it will also suggest fixes. All of these are equal. But I think that the nicest part is that it's domain-aware type error diagnosis. So this is written with a brand of Deutsch's parser combinators of all days. So these are pretty straightforward parser combinators in terms of their performance and what they do. But as you can see, I mean, I write a simple parser for a lambda abstraction. So this is the slash, this is the arrow, this is the list of identifiers, and this is the body. The only mistake I made actually is that I wrote this larger than sign. Because this function takes two arguments, the result of the folder and the result. I can throw the token away, but I forgot to do it. And this function takes two arguments, but it gets three. And this is the error message that results. Okay? I guess everybody agrees that this is a large and complicated error message. It's very hard to find where is the mismatch. I mean, where does it actually go wrong? There's no mention of parsers in the error message, and I built these things, and I only know about parsers. So that's not very nice. And as it happens, it's a common mistake. It's easy to fix. The only thing you need to do is replace this by another operator that's very much like it. Works like a charm. Alright, so what we did is we brought the type inference mechanism under control. In the sense that we phrase it as a constraint solving problem, and we provide hooks for specializing type error diagnosis. But changing the type system is forbidden. We don't want to make any changes so that the programs go through, that they shouldn't go through, or that programs are rejected, that shouldn't be rejected. And what you do is for your source file, you just write a type file that contains a number of directives. And let's skip immediately to one of these directives. Basically what it does, you just give some type inferency like syntax for saying, well, if you have an X, specific, so this is a parser application, you apply a function to the result of this parser, that's the idea. Then you have here the X and the Y, so these are arbitrarily complicated sub-expressions, but they're the left and right argument of this particular operator. And now I write down all the constraints that should hold for this to type check. And now for every constraint, it's as simple as that. I can just write a specific type error diagnosis. If this constraint fails, then I can write this, and I can mention the things like parsers. And I can do this once, and as a DSL developer, ship it together with my source code, and people will get messages like this. Map to upper apply to hello world. Well, this is a string, not a parser of that string. Right operand is not a parser. Of course, this is not a very good error message. So what you can actually write is you can use all kinds of information that the compiler can find for you in this particular sub-expression, like the pretty printed version of the whole expression, like that, or the type, particular type, and then you get error messages like this, which is like what you expect. Yeah, so it has location information, it has the actual expression. So this is the kind of thing you can do. It sounds complete in the sense that all the type rules that you write in this way are checked, that you don't forget any constraints, that you don't have too many of the constraints. This is all checked. It must be checked because it's very easy to make mistakes. We did it lots of times. There's another directive, siblings, that I find very nice. Is, for example, if you know that people confuse this operator with that operator, you can write this down in your file. You can just say, okay, whenever you see a mistake that involves this operator, just try that one, see if it works. And if it works, suggest it as a fix. Another one, for example, is when you have PHP programmers come to you and they say, we want to learn about Haskell. Evangelize it. So what you could say, well, they are probably used to writing dot for string concatenation, because that's what they use, right? But for us, it's function composition. So what you could say, well, plus plus and dot are siblings, and then it will suggest these things as well. All right. So actually, if you go back to this example, it would actually suggest to replace this. Sorry, I changed the example around. I hope. Alright, it can also permute function arguments, so suggest flip the arguments to a binary function, for example, these things. Please. So, to wrap up, quick about this. Task in the near future, we have a Java-based IDE for Helium, but I'm not sure whether I actually want to publish that as well on Hackage. It will only mean more work for Duncan. But who knows? And maybe we'll build something, or maybe we'll just leave it like this. I mean, you have your GHCI, you have your run Haskell, as it will be before. we had, I wrote a server for receiving all these blog programs. So maybe I want to publish that as well, I'm not sure yet. I want to fix those pesky bugs. And we already know how to make text a little bit more friendlier to use. So there is a dilemma though. So this is more the future, the further away future of Helium. I have a dilemma. So currently Helium is too small so for our own functional programming course. That may also be that other people also have this problem, right? And maybe if you've been to the SRC, the Student Research Competition, Alejandro Serrano-Mena, he's working on extending the ideas of Helium to Haskell 2010 or 2014 or 2029, I'm not sure when it's finished. And to build that, should we build that into Helium? So our current idea is actually that we will build that into the UHC, so that's UTS's, the Voices Compiler. Why? Because they have already done a lot of parsing. And you have code generation and lots of stuff I don't want to care about and worry about. So I hope that is actually less of an effort for me than extending Helium to also be able to deal with GADTs and type families. But UHC is a research compiler. It's not intended for student use. So there's a dilemma that I don't yet know how to solve. And of course, maybe it's successful. We actually can build whatever we have in UHC, but also in DHC. And of course, I mean, now we are using DHC and P. Why we should change it then? But I still don't know. Maybe I'll build type classes in so that you actually have a sizable subset of Haskell. Okay, Helium is, so I hope I've not discouraged anybody to contribute, because I mean you can contribute if you want. It's open source, it's on some SVN repository. But if you want to have the mid-rise, I need the repository, it's SVN, right? Centralized. Mail me the address, and if you have any bugs, because I imagine everybody has installed Helium by now. Bugs, and you can also use it there. It's reassuring to know, I think, at least for me, for my heart, that Helium is on Hackage. And if you know a little bit about Helium, it's almost impossible to freeze. Thank you for attention. Questions?
So at ICFP, Norman talked about teaching with student languages, and so I want to ask about going in the other direction from extending Helium. Have you thought about even more restricted subsets? So, so Norman talked about an initial language that doesn't have any local variables, or you might prohibit students from defining polymorphic functions. I wonder if you could potentially get better error messages for beginners in those situations.
Oh, I'm certain you can. And I think recently I read a paper by Yuki Ishii and Kenichi Asai. This is an OCaml set. So they also introduce language levels for a type debugger. And they could also say, if you don't, for example, allow higher order functions first. And then if people accidentally have an higher order function, you can give much more precise error messages. The question is, how easy is it to engineer that in this setting? And that's the hard part. Of the language levels is not that difficult, but engineering that and controlling the variations that you'd like to have in terms of the type error diagnosis, that's a lot of work to build that in. I do think that that's complicated. So I have to talk about domain-specific type error diagnosis, because basically what it gives you a hook for kind of imposing your will on the type error diagnosis that you get. For example, you could say, you don't get any kind of great fix like this, but if you make a mistake like that, go off and read page 20 of the reader, collection notes. And I guess that it already gives you the facilities for kind of tailoring the error diagnosis in a way that you can actually say, well, I assume you write code with in a particular normal form, a particular subset. And then you can actually already exploit that here by saying, well, I know that they can't be writing code, they can't mean to write code like this, or code like this, or code like this, because I forbidden them to do that. Of course, the parser doesn't forbid you. But then at least you can say, well, this is what you must have done because I know you can't be writing code like that. Or you could say, you can write code like this. I think you can get quite a long way already using this, but having real language levels, it's much harder, I think. And yeah, I mean, I thought about it, but it's just the effort that I think is involved, and also the increasing complexity of the compiler. Because as it is, Helium is a very straightforward compiler. I mean, even I get that. It's really straightforward. And yeah, I'd like to keep it that way to some extent, but personally, I mean, actually, when I teach FP to my students nowadays, then actually, I don't hear them complaining anymore about the type language. Once you warn them about what was true.
More question?
Yeah. Could you imagine using Helium as a compiler its own, but rather just a front end for GHC, so that it take the student module, compile it, type check it, so that GHC doesn't have to complain anymore.
Yeah.
But then you can import, let's say, gloss or diagrams or other fancy stuff.
Yeah, so I thought about that. One thing that has also put me off in that direction is that what happens in Helium is that all the information from the .type files that I add this diagnosis are stored in our object file. So then I need to find a way to store that in the high files as well. Sounds like a lot of engineering, but I don't know.
Okay, let's thank the speaker again.